In this lesson, we will look at Unit 2, Section 2.5, using the sine and cosine ratios to calculate lengths. In this lesson, you will learn how to use the sine and cosine ratios to determine lengths indirectly. Indirectly means you're going to use some kind of strategy to solve for the missing lengths. You will not use a direct measurement of a measuring tool. You're going to use either a sine, cosine ratio to help us determine what is unknown. So the sine and the cosine ratios, just to refresh from our previous lesson, sine theta equals opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. We can use either the sine or the cosine ratio to write an equation that can be solved to calculate the length of a leg in a right triangle when the measure of one acute angle and the length of the hypotenuse is known. So when using the sine or the cosine ratio, you can use it and write the equation to help determine the length of an unknown side. Similar to this example, where we have to determine the length of the indicated side to the nearest tenth of a centimeter. Looking at our triangle, we first have to determine if the sine or the cosine ratio is most appropriate. We will look and label our right triangle according to the theta or the degree that's given. So we have 72 degrees for angle K. The opposite side of angle K would be NM, which we do not know. So we're not given the opposite side. We need to find little m, which is side K to N, and that is the adjacent side. So we need to use the adjacent side. And we're given the hypotenuse, which is 5.5 centimeters, since that is the side opposite the 90-degree angle. So in this example, we're going to use the cosine ratio since we need to find the adjacent side and we're given the hypotenuse. So cos, so 72 degrees, equals m divided by 5.5. We're going to multiply 5.5 on both sides to isolate the variable of m. 5.5 times cos of 72 degrees equals m. Make sure and double check that your calculator is in the degree mode, and when you do that, you will get an answer of 1.7 centimeters. And what if we just wanted to extend this question for a minute and say that we want to find the third side? We can actually find the third side using the Pythagorean theorem because we are given the hypotenuse, which is 5.5, and we just determined the measure of m, which is 1.7. So Pythagorean theorem can be applied here to find a third side. If we want to extend the question again to find the third angle measure, we would have to go 180, subtract 90, subtract 72. And when we do that, we will determine that that angle M will be 18 degrees. So you can see quite clearly that a question that asks you one measurement can be easily extended to use the Pythagorean theorem to find the third side, or you can be asked to find the third angle measure when given two already. So in summary here, the sine and the cosine ratios can be used to determine an angle given one leg and the hypotenuse, or it can be used to determine a side given the angle and one side. And in these three different examples here, you can see how the sine and the cosine ratios can be applied in different ways. In the question on the left, you need to use the sine ratio to find angle B, and the cosine ratio could be used to find angle A. So cosine and sine ratios can be used in the same question to find different parts of that right triangle. It depends on if you need to use the opposite or the adjacent side. In the second triangle, we can see there that the angle B is given, the adjacent side is given, but we need to find the hypotenuse, and we'll use the cosine ratio there. And in the last triangle, we are given angle B, we are given the hypotenuse, but we will have to find the opposite side. We will use sine ratio there and find that it will be 6.1. So sine and cosine can be applied in different ways to find the angle measure or a side length. So right now we have three ratios that we can use: SOHCAHTOA, sine, opposite, and hypotenuse; cosine, adjacent and hypotenuse; and then tan, which is opposite and adjacent.